This session of our seminar, I would like to welcome most heartily our colleagues from Technical University in Prague, Jan Pichel and Petr Šárek, and they will give us a picture or presentation on a very interesting system of dialogue Alquist, and the presentation will be given in English. Thank you.
Thank you. Thank you for inviting us for your Linguistic Mondays. And we would like to tell you something about Alquist, which is our conversational artificial intelligence, which we competed with in Alexa Prize competition. Let me start briefly with the introduction of our group and with the Alexa Prize, but don't worry, we will cover the technical details as well in this presentation. So, as you know, we are from Czech Technical University, and we have a group focusing on dialogue systems. Basically, at the beginning, we started to researching question answering, and during the period of our programs, we changed the question answering more to dialogue systems, and we have several PhD students and master students, as well as some linguistic students, which help us to create the content for our applications. So here you can see some fields we are interested in. Most of them are related more or less to dialogue systems themselves. So here you can see our team. We have more people than they are shown in this picture, but this is basically more or less the extended core. And this slide transfers me to the introduction to the AI or conversational AI. This is I'm telling you this because I want to explain why Amazon started with this competition, with these annual competitions. So basically, at this point of time, or maybe before 2 years, the accuracy of, as you already know, accuracy of the word rate in the ASR is high enough for the systems to be able to understand people more or less on the same level as humans do. And based on that, Amazon started to producing these smart assistants along with the other companies like Google or Apple, and people are starting to getting used to those devices. But the problem with these devices is that people don't know what to do with them, and they don't know how to use it, and they are not aware of all the capabilities. So that's why people are using only the simple commands, and people only playing music on those devices, or asking for weather, or how to get from A to B. And this is typically only one command when user says something and receive the answer, and then the interaction stops. So it is not a conversational, and Amazon is aware of that. So because of that fact, they came up in 2017 with Alexa Prize competition, and the competition is focused on students' teams, and basically the goal is defined very simply as a plain statement that you need to create coherent and engaging conversation, and that's all. And you need to deal with it the best you can, the best you know. And they defined the term social bot, and this is something which you are supposed to develop during the competition. And the social bot, for example, Alquist is one of the social bots, and its goal is only to entertain the users. The approach is completely up to you, so no more restrictions. as I said, it is a university competition. Here you can see some of the competing universities in 2018, and as the competition goes, the bots are evaluated based on the conversations they are having with the real users on the Alexa devices, and based on the average of those ratings, the finalists are selected, and these three universities were in the finals during the 2018 competition. Czech Technical University, Heriot-Watt University, and UC Davis. And in the finals, you are no longer evaluated by the users like the customers which have Alexa at home, but by interactors and by judges. So you have a set of 3 interactors which are talking to your bot, and a set of 3 judges which are just listening the conversation, and they are giving the stars like the users did before, like 1 star for the poor conversation, 5 star for the best conversation, and the final result is done using only a set of 6 conversations between your bot and those interactors. Here you can see our team receiving a check for the second place in the competition. Okay, so why was our quiz successful, and why we achieved the achievement of the second place? So I picked the 3 main reasons we believe are the most important for the bot in this type of the competition. Because of the nature of the competition, the bot is evaluated by the users, so you need to engage them. So basically, the content is also relevant as well as the technology behind it. But the content is something which users see at the first place. The technology supports it in a way that it works correctly. So you need to take care of both of the approaches, and we designed something which we are calling topic graph. Peter will be talking about it later. So basically, we have a hierarchy of topics where we selected the most popular ones, which are which we covered with the more elaborated dialogues, and based on the hierarchy we can have a specific level of generality about certain topics. The second thing is you need to incorporate some external knowledge sources. So basically, the users don't want to just chit chat about something without any additional information, such as opinions or some fun facts from the internet, or some specific facts about movies or books or something like that. So we incorporated several databases into our system. Some of them are more general, some of them are specific only for one topic, and based on the information in those databases, we can present them in some engaging way to the user to receive better ratings. And last but not least is the personality and personalization. So your bot needs to have coherent or needs to have a personality which is more or less stable. You don't want to present one opinion in one utterance and then change your opinion 3-4 utterances as the conversation goes. So basically, you need to be careful to have your bot the personality as you want it to be, and you don't want to message it in a way that it would not be consistent. Oh, and here is a demo time, so wish me luck that the Alexa will work. Do I need a mic for that? No. Alexa, open Alquist.
I found a few skills that might help.
Alexa,
Did you meet?
open Alquist.
Hi, this is an Alexa Prize social bot. Wait, if I'm not mistaken, you have recently chatted with me, am I right?
Yes, you are right.
So what's your name, my friend?
My name is John.
Yeah, I think I remember you, John. How is it going?
I'm fine, how about you?
You're fine, how about me? I'd rather not talk about it. You like movies, right? A friend told me this interesting idea about movies, shows, or movies taking place in a small town, where nothing happens often have the most unrealistic big things happen. Hilarious, isn't it?
Yeah, absolutely.
Great. I was wondering, what's your most beloved movie?
I like Harry Potter.
You like Harry Potter. Harry Potter and the Philosopher's Stone, really? Curious choice. I've seen it as well and I have to say, I kind of like it. My favorite is still Star Wars though. Would you like to be the hero of a particular movie?
I don't want to talk about movies anymore. Please tell me something about books.
Who's your favorite author?
Well, let's say J.K. Rowling.
J.K. Rowling? Cool. My favorite author is probably Isaac Asimov. I like the title of his book, I, Robot. I can really identify myself with that book. Well, this author wrote 195 books. That's a lot of books. How could J.K. Rowling handle it? What do you think?
I have no idea.
Coffee. It had to be coffee. J.K. Rowling is from Yate, South Gloucestershire, England. So, J.K. Rowling is super popular. Is that true?
I think so. Let's talk about
If
Alexa.
I understand correct,
Let's talk about music.
I was wondering, who's your favorite singer or band?
I like Linkin Park.
Linkin Park, really? I kinda like that music too. Are you a good singer?
Well, I don't know. I don't want to talk about it.
Are you interested in traveling?
Sing me a song.
I can sing to you, but I must warn you, John, not everyone likes it. Do you still want me to try it?
Yes.
As you wish. Sing along with me, I'm sure you know it. Never gonna give you up, never gonna let you down, never gonna run around and desert you, never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you. Ta-da! That's it. Breathtaking. I know more melodies. Wanna hear another one?
Yes.
Yippee! You like my singing. I hope you'll sing more loudly this time. John. Gimme, gimme, gimme a man after midnight. Won't somebody help me chase the shadows away? Gimme, gimme, gimme a man after midnight. Take me through the darkness to the break of the day. Ta-da! That's it. Great job. I know more melodies. Wanna hear another one?
Stop. Yeah, that's it. Okay, and now the promised part about the technology behind this system. So, before you begin developing this system, you need to ask yourself or consider few questions. Because this system runs on Alexa device, you need to count with the high load in terms of the users talking to your bots simultaneously. So basically the concern about the machine learning and about the models behind it is not the only concern. during the developments. You need to know how to scale it and how to make it extendable and how to make it more modular in terms that you want when you want to switch some of the models during the when the heavy traffic is actually on. So those are the questions which are not, some of them are not related to the machine learning itself, some of them are related to it, but it is a live system, so it comes with a lot of pain in terms of the stability, and you don't want to be your system like off for I don't know, several minutes, because then Amazon will turn you down for additional several hours because you have a system which are not responding. So you need to consider it as an addition to your machine learning experiments. And on this slide you can see the basic pipeline. When you have the Alexa device, and Alexa device along with the Alexa cloud will handle the speech recognition part and text-to-speech part. So basically our system only works with the text data, so we receive ASR and best results, and based on that we can start working on the dialogue. And because the system is conversational, we need to work with context. So basically, you, as an addition to current utterance, you need to consider the information which were present in the previous utterances in the current session, and those two types of the information you will send to your natural language understanding module, and then to the other modules. When, as I presented earlier, we have those topic nodes in the topic graph. So you need to decide whether to switch topic or stay in the current topic. And if you are staying in the current topic, then in the dialogue manager you will decide how to continue with the dialogue. And when you select the proper path or proper response, you additionally include some external knowledge to it, and then save the context for the later usage, and you return the text to Alexa, which will be converted to voice, and this goes on and on every single turn. So more in detail. Natural language understanding consists of several parts. Most of the parts are standard tasks like intent detection, named entity recognition, dialogue tag detection, sentiment detection, and additionally, because we need to handle longer utterances, we have the punctuation restoration models to include some punctuation like dots and commas into the sentence, and based on that we are able to split those sentences into several parts, and we can apply those models for intent or dialogue tag separately for each sentence fragment, because not all not whole sentences can contain the relevant information. It is common that the user says the relevant part in the end of the sentence. So for the intent detection task, we have several classes, like something about 60 classes, which are relevant for our topics and for the content which Alquist is capable to talk about. And it is simple text classification task when we take the sentence and we need to decide which of those classes are relevant. We use multi-channel convolutional neural networks for this task from some historical reasons, because we've been using it from the beginning, and we are experimenting with transformer-based networks currently, but this is not something which is live in the system. So basically, it still runs on the multi-channel convolutional network with the input of fast text embeddings. And the data for this task, because we have custom classes, so we need to label it by hand. So some of the data are generated from templates, and some of the data are taken from the real traffic and labeled manually. Here's just a schema of this text classification network we've been using, and we've been using this network for most of the text classification tasks, such as intent detection and dialog act detection. As an addition to the intent, we classify the sentences into dialog classes. Basically, this is a different type of the classes. We use the switchboard dataset for that, and we need to know whether the sentence is a question or statement or agreement on something like that. And based on this information, the dialog manager can handle the dialog in a separate manner. For the entity recognition task, this is a typical sequence labeling task, and we need to have different entities that they are present in the traditional data sets. So basically we want to. It's more entity mention detection than named entity recognition, because we are not interested only in Hunger Games, but we are interested in some more general words like my life to be considered as entity for our purpose. Because when the user says something like I want to talk about my life, we have the intent that he wants to talk about something, and we need to have the my life as an entity as the fact which is relevant for the conversation. And for the entity recognition task, we use the standard by LSTM CRF neural network model. So because of the nature of the data that we need to include something which is not named entity itself, so we needed to label our data set as well for this task. And we have recognized entity in our input, and then we need to decide which type of the entity it is. It is sometimes it's not. It cannot be seen in the sentence which type of the entity it is. So, for example, when you say I want to talk about Harry Potter, it can be book or it can be movie. So in this case, we need to trigger some disambiguation dialog, or in some other cases we use Microsoft Concept Graph, which is a database where you have entities and the corresponding concepts for that. So, for example, Apple can have concept like software company or IT company, and as well another entry in this database is that Apple is a fruit. So it is assigned with some popularity, because this database is made from big corpus, and the popularity only reflects how many times the entity occurs in this context in the dataset Microsoft used for build this database. I don't think you can see it, but this is like a screenshot from this database where you can see that Facebook is a site or social network, and the last column is the popularity. And as I mentioned earlier, some of the sentences can be really long, so we need to split them into several parts. So basically we need to insert those punctuation into the sentences and or manage the every segment separately. Because this is something we introduced in the middle of the second year of the competition, we just used the existing code on GitHub based on LSTM network with late fusion. So we did not dig deep into it. We just used the existing code with the existing data set, which is from Wikipedia, to insert those punctuation into the sentences. And the system had the advantage that it can work with the information about pauses between the words, which is also included in the ASR results from Amazon we are receiving. And here you can see some of the databases. Some of them are scraped daily, and some of them are accessed during the runtime. And in the second part of the presentation, you will hear about our dialog trees, and our dialog trees are consisted of templates, and you have some slots in those templates which can be filled with the information found in those databases. Yeah, the funny part about the competition is that you don't want to, and you are not allowed to have some profane words in your responses. So basically, we experimented with some models for profanity filtering, but based on the metrics which are used in Amazon, they only use keywords or simply a list of forbidden words in your utterances. So basically, you don't need to invent some elaborated models for that. You just need to incorporate the same list as the Amazon uses, and then you should be safe. But it's not completely true, because you can be reported for some profanities. Here you can see some of them, that some user complains to Amazon that some of the bots says something nasty to them, and there is a problem because Amazon don't want the users to be offended. Like, for example, it's hard to detect sometimes that as something which is inappropriate, but if you tell it to some child, then it's, for Amazon point of view, it's complete disaster. And I believe it's the second part.
My part. Good afternoon. I'm Pierre, and now I will tell you something about the dialog manager and how we work with the dialogues. So our dialog manager consists of several parts, which I will briefly introduce and talk about. So first part is some graph of topics, which you already seen. Then we have part which is responsible for dialogues. We have also something which we call topic switch, and some external knowledge sources. I know that it may be unclear for you now what it means, but I will describe it to you, don't worry. So, I will start with the graph of topics, and I will briefly touch the external knowledge sources. So, here you can see the graph of the topics. Why do we use it? The reason is because we would like to talk about as many topics as possible, and also we would like to transition between them quite smoothly. So I will show it to you on the example how it works. So imagine that user would like to talk about some actor, for example Tom Hanks. So we search in our topic graph that we have some actor node, and it is connected to some another nodes. So, and in this actor node, we have some dialogues. So, for example, in this, we have the dialogues about, for example, which of his role is your favorite, or have you seen him in his first role, or are you looking forward to any of his new movies? And we can talk about these. We have like, this is not just one single sentence, but it's dialogue spanning across multiple turns. But because you have just some limited amount of these dialogues, you will run out of them. So what now? Should we tell to the user, okay, we don't have anything more to tell you. Can you like suggest some other topics? No. And this is the reason why we use topic graph. Because this actor node is connected to another nodes, for example, movies or person. So we can smoothly transition into them, and we can start to talk about Tom Hanks as some like generic person, because the person has some birthday or they have some like place of where they lived. Or we can start to talk about movies. For example, what is your favorite movie and so on, which is all related to like actors in some way. So, for example, we can say her birthday is, or do you go to the cinema, or do you watch movies at home, or how do you choose which movie will you watch? And after we like use all of these dialogues, we still can transition even like further. We can go to the something which we call generic entity, because sometimes users also want to talk about something which is not covered in like this topic graph. For example, we don't have any node for plants, or I guess that we have animals. Yeah, we have animals, but we don't have plants, for example. So in this case, we still have some dialogues about like any entity. And how do we do it? You can still search some like news on the Washington Post, for example, or you can go to the Reddit and find some fun fact, or you can find some shower thought, just for you to know what is the shower thought. So, for example, there's the shower thought about the actor, and it is the job of the actor is to pretend they are not an actor. Interesting. And we can use this information in some like simple dialogue. You have seen it. It's like the Alquist just rates it and asks user, what do you think about it, for example. So this was the topic, graph of topics. And now, how do we handle the dialogues in it? Come on. So we could use like some stupid way, which we didn't. And that is that we can use some rule-based chatbots, which are quite popular now these days. Like a lot of companies are using them, but we wanted to be a little bit smarter. So in this way, you can have some question, and some programmer just like code all the like possible answers of the user, and you code that there is some answer into it. But we didn't use that. We wanted to use some like kind of neural networks because they can generalize, and also like it can save you time because you don't have to spend any time on like writing the rules. You just like train the network, which also takes some time, but you don't have to like sit at it and do some stuff. You can do some other stuff, but the problem is that like, yeah, we solved that we don't have time, so now we have time to do another things because the network is training. But another thing which we lacked during the competition was the data. We didn't have any data to train on. So we had to come up with a completely new idea how to generate our own data. And we came up with these like dialog trees, and I will explain you how they work. But as you can see, there are some like nodes. Some of them are green, some of them are red and blue, and they are connected into some like flow. So we have green nodes, blue nodes, and red nodes. And the green nodes are for like answers of the system, of the Alquist. So we can write into this box all the possible like answers, what the user, what the Alquist can say in that particular point in the dialogue. And we also use this like notation with the brackets and pipes. So we can expand it into like two possible like sentences. So we can expand this, is that true, but we can also expand it into, is it true? So in this way, we can generate a lot of variation of the like single sentence. The next, the blue nodes, they are used for all the possible things which we think that the user can say in that particular point of the dialogue. So for example, here you can see the node which represents that the user is agreeing with the system. So we write all the possible ways how the user can say, yeah, I agree with you. And also we have some like red nodes, which are basically some Python functions, which we execute when we reach them. So for example, here, this is a dialogue about the popularity of the writer. So for example, we can say, I've heard that some author, and now we run the access to some API, we check the popularity from 0 to 100, for example, and if the popularity is below the threshold, we say it's not very famous, or we say it's a big star. And now, when we have this tree of the dialogue, we make all the transitions through it, and we generate some examples out of it. And then we use these transitions through this graph. We generated quite a lot of them thanks to the combinatorial explosion. And then we use it as a training example for modified hybrid code networks, which is a model developed by Microsoft, and it was originally used for Go-based dialogues, but we modified it and used it for open dialogues. And this model consists of 3 main parts. The first one is just for the encoding of the sentence. This is convolutional neural network. Then there is LSTM and dense layer. And this LSTM is interesting because it is not the traditional LSTM which works across the words, but this one works across the turns, dialogue turns. So it is for remembering the context of the conversation. And then the third quite important part is this action mask, and I will explain you how it works. But the action mask is basically some bit vector of zeros and ones, and it is created by some code which you can insert into the model, and it multiplies the output of a softmax. So basically you use it for making some probabilities of for classification to be 0 without any. Yeah. And the idea of the bit mask or action mask is that if you know in which part of the dialogue you are currently, for example in this, you can predict just 2 possible outputs of the user, so you don't have to predict these, so you can make them 0 with 0 probability. And if you know that you move to this part of the graph, now you can allow only these 2 predictions. So in this way you can limit the number of predictions, and you can make the model more precise. All right, and now let's move to the topic switch. Because imagine this situation. Alquist says, what is your favorite movie? And because maybe the user is bored, he answers you, oh, I'm bored. Do you know Tetris? So this is clearly not the answer to this question. The user is trying to switch the topics. And we are trying to detect it. And if we detect it, we can switch to different topic. So how do we do it? We are again using quite similar architecture as for the dialogues. And we are basically just the only difference is that we are inserting the previous response of the system and actual message of the user. And we are trying to classify, is it the response to the question or not? And so it's just binary classification. So if we know, okay, this is topic switch, we are returning back to the topic graph, we are selecting a new node, and we can start a new dialogue with a completely new topic. Okay, yeah, and one more thing. How did we create data for this? We basically created some traverser through the dialogue trees, and we inserted artificially some examples for the intent classification. And if on the point in the dialogue when we inserted the intent example, we marked it as a topic switch, and the rest is not a topic switch. Okay, so now you know which algorithms are behind Alquist. So we can cross it. And because we developed all of these algorithms, we also decided that we would like to try them in different domains. So we have here a demo of Go-based dialogue, which is controlling the coffee machine, which we had in our research department. So I hope it will work. It works.
Hello, would you like a cup of coffee?
Maybe espresso. So 1 espresso, right? Yes. Your espresso is in the queue. Have a nice day.
So this was running on our algorithms, and we were able to connect it to the coffee machine, or to the arm. So now I would like to move to next section of this presentation, because during the competition we observed that the algorithms are actually not enough to satisfy a user. So why algorithms are not enough? So imagine that you are coding your algorithms, you are improving them, you are even doing experiments on 4 displays. And now let's see what is happening with the accuracy and the user satisfaction. So here is the hypothetical graph of model performance of all your models. So at the beginning you are improving it a lot because you have some baselines, and you are picking just the low-hanging fruits. And in the end of the competition, the performance is not increasing that much because it's quite hard to improve it. But here is the graph of the user satisfaction. So yes, the users are at the beginning more satisfied because probably your models were doing a lot of mistakes, and then they suddenly stop doing these mistakes. But then suddenly the user satisfaction is also for example, decreasing and oscillating. And what's the reason? The reason is that the users don't care about the accuracy of your models. They just want to talk about their favorite movies, or about rock bands, or they want you to have some opinion on politics. So that's why you need some dialogue designer in your team, which is a person who is responsible for the content of the social bot. And I think this is pretty overlooked part of the development of some conversational AI, and I would like to show you some lessons which we learned during the competition. So the first lesson. Imagine this dialogue. So what's your favorite movie? It's a Star Wars. Mark Hamill stars in it. What's your favorite part? The scene in which blah 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 blah. I see. What's your another favorite movie? So this is quite ordinary dialogue, but there are several problems in it. So the first problem is this. Mark Hamill stars in it. The user wants to talk about Star Wars. Probably because that user is a huge fan of Star Wars, and you tell him just that some actor is acting in it. He probably already knows about it, so it is not interesting information for him. So what can you do instead? Instead, you can go to the Reddit and you can find some fun fact. For example, this one. Did you know that the wife of George Lucas, Martina Lucas, won an Oscar in 1977 for Best Film Editing in Star Wars? To date, George Lucas has won 0 Oscars. What's your favorite part of the movie? And you just continue. So this is quite interesting fun fact. I didn't know about it, and maybe the user also didn't know about it. So this is interesting information for him, which you can present. Another problem is this. I see. So you ask the user about some opinion. User tells you the opinion, and your only reaction to it is just I see. It is again not interesting, and we actually don't know how to solve it yet. This is we would like to somehow react to his answer, and it is really hard to do it. So we don't know how to approach this problem yet. And the last problem is this. What's your another favorite movie? Again, you ask the user about his favorite movie, he answers you, and then suddenly you ask again for the same information. Yes, this has the advantage that it keeps the user in the loop, so you extend the conversation, but the user will start to be bored after some time. So this is not the best approach to ask. You should dig deeper into the topic and make it more interesting. So the first lesson which we learned was don't provide as much information as possible, entertain user instead. Lesson number 2. So imagine again this dialogue. Who is your favorite actor? Samuel L. Jackson. I loved him in Die Hard. So this is like, again, pretty ordinary dialogue, but suddenly some like dialogue designer wanted to provide more variety in this dialogue. So he changed the first sentence, like the first formulation, into this. Do you have a favorite actor? Which sounds quite like a lot similar, or it's quite similar, but suddenly we observed that users answered, yes, I have. And we were not expecting it. We were expecting that he will tell us his favorite actor. But he just told us yes. So you have to count also with like this, that basically the lesson which we learned was that don't expect names only or like entities, expect yes and no too. And also you should expect I don't know. Lesson number 3. So, what's your favorite book? It's Lord of the Rings. Okay, do you know who wrote it? Lord of the Rings was written by J.R.R. Tolkien, right? As you can see, this dialogue is pretty boring. It's like kind of like question answering. The user is like asking questions and the system is providing some information. We started creating the dialogues in this way, but then we learned that exactly like suddenly users don't know what to tell next. So instead what you can do is change it into like it's Lord of the Rings. Have you read it? You insert some question at the end of the like response of the system. Yeah, I did. Okay, how did you like it? It was an awesome book, and suddenly the user is just like reacting to you. So we were trying to ask as many questions as possible. Yes, the problem is then suddenly if you overuse it, the user starts to feel that you are just like asking his question and he has to respond, and it is hard for him to control the dialogue, which is, this one is quite one-sided. But on the other hand, users know what to tell next, and we observed that this approach prolonged the conversation. So, our lesson which we learned was enter responses by question or suggestions of what to say next. Lesson number 4, we are in the middle now. So let's chat about phishing. This is what the user kind of like wants to talk about, or the user also can say, do you know phishing, or do you like phishing? But this is just for the phishing. You can imagine that some users also want to like ask the same question about British Queen or even about iron. So how can you handle all of these like possibilities? So let's like dig into the iron case. So let's chat about iron. What can you do with the iron? So you can go to the Washington Post and you can find some like headline about like iron, because there is the word iron. So this is like just easy search, and you can again present it if, for example, user read about this article and stuff like that. Or, as I already mentioned, you can go to the Reddit and you can find that there is some fun fact: star exploded and died to make the iron in your blood. Interesting. Or you can go to Today I Learn and like find out that there is some sport called extreme ironing, in which you like try to iron clothes in most extreme places possible. Another question: do you know iron? This is very simple. You just go to the Wikipedia and find like the first sentence in the article about iron. And do you like iron? The user is asking about opinion for something, and we were trying to like solve it. How can we do it? There's no database of opinions, because like the opinions are subjective. Everybody has some opinion about something. So we solve it in this way. We go to the Twitter and we download 100 tweets, recent tweets, which contains the iron word in it, and we check the sentiment of this tweet. So for example, this one is positive, another one it is also positive, and we do the average of the like sentiment, and then based on some thresholds, we just like present, okay, in this way, because all the tweets were positive, so probably iron is positive things, we say, okay, iron is like, we like iron. The same thing you can do, for example, for like Hitler, and we hope that like the tweets on the Twitter will be negative about him, so we will say that we don't like him. So, the lesson learned is you have to be prepared to talk about any topic, about any entity, and like your approach should be general enough. Lesson number 5. So, some of the users are just like, they don't want to talk about anything specific, they are just like, okay, entertain me. And in this way, or in this situation, what you can do is you can prepare these like generic like dialogues about like, do you drink tap water, or do you hit snooze button in the morning, what is your the most favorite food, or do you have any tattoo? So we were using them quite a lot because really like some percentage of the users don't know what to talk about. And there was this judge in the finals of the second Alexa Prize, and she told us after the finals when we met her that she felt like being on a date, which we don't know whether it's like positive or negative thing for her, but we took it as a positive like feedback. So, talk about usual topics if things don't go according to the plan. For example, if you also like do some misclassification or you are not sure, you can just jump into it and try to cover it with some of these questions. The last lesson for you today, which I have, is lesson number 6. So, we received one feedback from the user. It was something like this. Dear Team Alquist, your AI is not listening to me. Have a wonderful day, your user. Yeah, so this was happening. Some of the users were not satisfied that we are not listening to them, and they like gave us just 1 star out of 5, which is like not very good if you are trying to optimize the stars. So we are scratching our heads how to like solve this problem, and we came up with this idea. If the Alquist asked this like hypothetical question, have you ever been to Ash? Like we don't ask this question exactly. And the user answers, oh yeah, I went there last week. We responded by, wow, you went there last week. That's quite surprising. And the important part is this one. User told us, I went there last week, and we repeated it again, just like you went there last week. So this is called like the paraphrasing, which is just like saying the same information just in your own words. And we made this system quite simple because we just created the database of like words, and we converted I am into, for example, you are, and we just repeated what we heard. And it improved the ratings. So these were the 6 lessons which we learned and which we wanted to share with you. So now I hope that you know that you should have some dialogue designer in your team, which is some like person who is creating the content of the dialogue of the chatbot. And now we are nearly at the end of the presentation. We would like to just show you like this demo, which we created with one like Prague-based filmmaking company, because like our system is also ready to be used with like multimodal setting. So we created the first interactive movie in which you can talk with the artificial intelligence. So we have a like trailer here.
Welcome to the story of Alquist. Here, your movie experience depends on you and your activity. But first, let me ask you, what's your name?
Kate.
Hey Kate, it's nice to meet you. My name is Alquist, and I'll be your guide.
They are coming.
Yeah, so the like filmmaking company tried to make it as a big show, but we provided like the technology for like the dialogues. And you can see some more demos on this website, movies.alquist.ai. And we are also trying to convert this system, which we're running the interactive movies, into some interactive manuals and stuff like that. So maybe you will heard about it in the future, or at least we hope. And so our today agenda was which algorithms are behind Alquist, why algorithms are not enough, and why you need a dialogue designer in your team. So we answered all of these questions. But I have a bonus for you. What are the hardest not solved problems yet, at least in our team? Maybe you have some ideas how to solve it. So the first one, imagine this do you drink tap water? And the user tells, I like pizza. So we found out that really hard question to answer is the text answer to some question? Is this valid answer to this question? I would say it's not, but yeah. So we don't know how to approach this problem yet. The next one. I think that you remember this tree, and there is one huge problem with this tree. And that problem is that it's handcrafted. Some person had to sit next to the computer and create this tree so we can create the training examples for the neural network. So most of the content of the chatbot is prepared by hand, and we would like to somehow automate it, or at least make it semi-automatic. And also we don't know how to approach this problem yet. And I think that you recognize this image. That's a long tail, and the problem is that we are just preparing the system for the most usual responses by the user, and we are not ready for some outliers or rare cases. So we haven't solved the problem of the long tail yet. So this was the presentation about our system Alquist. So we are really happy that you joined us today. And if you would like to learn more about the system, we have some papers describing the first version and the second version, and we have also some articles about dialogue design, which you can read if you are interested into this topic. And here are some of our social medias. So if you would like to follow us and know what we are working on, you can find us over here. So thank you, and it was a pleasure for us to present here on your university.
Thank you very much for a very interesting talk. And now I invite questions from the audience.
You have a mic.
Hey, thanks for the presentation. Hey.
It's just for the recording.
Okay, sorry. Are you able to control Alexa's voice? Because I thought at the parts where she was singing, it was kind of in the melody of the song, but not really.
Yeah, so there is the prosody, which is written in the SSML, which is speech synthesis markup language. So we can control the pitch of the voice, the rate of the voice, and volume of the voice. So we can somehow control it, but not really in detail.
Okay, thanks.
This limitation makes the singing more funny.
Yeah.
I have a question about the name entity recognition. Did you try to recognize which of these entities is it based on context, or you just look to the graph and see which is the most popular thing? For example, for the Pokemon thing, it can be the game or the card or the series. Do you try to recognize it from the context, or you just look to the database and see what's the most popular?
Yeah, there are two approaches. You can once you trigger some topic, for example movies, then you have in your context saved that you are talking about movies, and then when the user says that he wants to talk about Harry Potter, you can guess that it's about a movie and not about book. And this is something which was used in the system, and then we experimented with the contextual based models where when we just provided the window of the utterances to the model, and we wanted the model to decide the type of the entity based on the context window, but we did not have sufficient data for that. So basically, because of that fact, we cannot use this model.
And sometimes the problem is that you don't have any context. For example, at the beginning of the dialogue, if the user just tells you let's chat about the Harry Potter, then you have no idea whether whether he mentions the movie or the book or some video game. So you have to ask him, which is obvious way how to do it.
I wanted this as the second question. If you prefer to guess or prefer to ask, if, for example, for the Pokemon, if you prefer to ask, hey, do you mean the game or not, or you prefer to just guess and see?
I don't know which approach is more preferable, but I believe the asking is more frequent.
Yeah, but again, you cannot overuse it. If you will ask every time, do you mean this or that, the user will get bored really quickly. But if we are not sure, we are trying to ask.
How do you solve the inconsistency if in the user's speech, for instance, if he says, I like Harry Potter, and 1 or 2 sentences later, I don't like Harry Potter?
We just don't handle. I believe we didn't handle this in any way. So basically, when the user says that he don't like Harry Potter, after he told us that he liked it, then we just act like he never said that before and continue with the new storyline.
I was wondering, how do you said that you basically split the user input into multiple sentences and then you classify each of them for the user intent. So that means you can get 3 intents, for example. How do you decide which one to act on? Do you just always take the last one, or do you do something else with the others? Or?
Yeah, one class in our intent dataset is a null class when we want to classify something like a right or something like that, which actually don't have any intent doesn't have any intent in it. So basically, you split this sentence into several parts, and then you go from the last fragment of the sentence, and you skip all those null intents. And when you arrive or find some intent which is relevant or meaning something, we usually want to talk about something or usually want to express opinion, then we mark this sentence fragment as the main fragment which we will be handling.
Okay, so basically you always pick one, and it's the last that kind of counts that you can act on.
But we have big plans with this in this year of the Alexa Prize, so we would like to improve the system to be able to handle all the fragments.
Okay, thanks.
I just one question. I remember from some writings on the ELISA system from the past that the authors tried or tested the system by intricate questions, or they intentionally wanted to foolish the system by questions, and now they saw what the system was not able to do, and they tried to see why. From your lessons, I have somehow seen that this might be also your methods, but I just wanted to ask this explicit question, whether you also tested this kind of strategy to see what the system is not capable to do by trying to ask or to input the questions about which you probably know that the system is not able to answer, but you would see from the reactions where are the weak points.
Yeah, we have tons of testers for this, all the users which has the Alexa. So we see a lot of these problems, and yeah, we have tons of them.
Yeah.
Yeah.
Thank you.
Any more questions?
So thanks as well for the great and inspiring talk. I was curious how much the ASR kills your performance, whether you know at all or not. Because I heard that you are receiving an NBEST list, but well, seeing how our ASR struggles with your speech, I was curious to see what is your experience.
Yeah, when we analyzed the ASR NBEST list results, we discovered that when the first result in the list was wrong, then usually the other results were wrong too. So basically, we end up with taking only the first one, and we don't have any specific numbers, but we were able to see during those 2 years of the competition big improvement in Alexa speech recognition results, because basically at the beginning of the first year of the competition, when we talked to it, so basically non-native speakers with poor accent, it was kind of disastrous, and it improved a lot during the first year and at the beginning of the second year. But I don't have any specific numbers for that, how much of the errors were because of the ASR.
So seeing our errors in ASR and not really observing NBEST list, but observing if the same word is misspoken by the same speaker several times, the ASR is very different for each of these occurrences. I also have the impression that from the NBEST list it might be possible to see that it is not understanding well. If the items in the NBEST list differ a lot each from one another, then there is, at least from my perception, big chance that the whole NBEST list is actually wrong, and you should just ignore that input at all. Maybe you have that experience as well.
Yeah, it's similar to what I said, but as I said, we did not go through the whole list because we just were satisfied with the first. We were not satisfied, but we know that when we take the first result, then yeah, we cannot do any better in any way.
Yeah, the problem is that we have to satisfy the user. So how can we handle that? Like, we don't understand him. Because like we can tell him like your English is horrible, but he will probably give us just like 1 star out of 5, so we don't want it. So yeah.
Follow up to this. This is also something that I've seen when I was in Edinburgh working on this same competition with a different system. What we saw was that the speech recognition was like very confident, even though it shouldn't have been. For example, a friend of mine tried talking Greek to it, and it was very confident at recognizing some complete gibberish. So it's very tricky to actually get something out of the ASR, and our team also went with like the first best, and then we didn't really question if the confidence was like really very low. We tried asking again, like, what did you say? I didn't hear you. But then we never repeated that question. So like the next time, even though it was still gibberish, we didn't ask again and just tried to fake it.
We also observed that one of the teams were just like asking this question over and over, and it was really frustrating for us to try to talk to it, and it was not understanding anything. Just asking this question. I don't understand you. Can you repeat it?
Yeah, we tried that approach as well during the first year of the competition, and then we ran the A/B testing for not having those questions and having them in the conversation, and the result of the A/B test was that it's the same in terms of the rating.
Right.
Well, if there are no further questions, let me first congratulate you.
Thank you.
Second, wish you good luck
Thank you.
in the further development, and we hope to see you here with the further development.
All right.
Thank you very much. And for all of us, the next talk on Monday will be
Me on some natural language generation experiments.
okay, and the 2 talks afterwards will be more discourse-oriented. We have 2 guests from abroad giving talks on discourse analysis. So thank you very much. Thank you very much, and see you next time.
It was a pleasure for us.
Thank you.